What if the newly discovered 3I Atlas isn't just another interstellar object, but in fact a nuclear-powered spacecraft sent by aliens into our solar system? And what if it isn't the first spacecraft to pass by Earth? Do you remember the mysterious arrival of Oumuamua back in 2017? This time with 3I Atlas, what secrets will we uncover? Back in 2017, astronomers detected a strange object, hurtling through interstellar space, slicing across our neighborhood like a cosmic spear. They named it Oumuamua, which in Hawaiian means a messenger from afar arriving first. At first glance, it seemed like just another comet or asteroid, but almost immediately, scientists realized that nothing about Oumuamua fit the categories we thought we understood. Its shape, its speed, its strange acceleration, everything about it whispered that this visitor might not be natural at all. Some even dared to ask, could this be an alien probe sent across the stars? Now fast forward less than a decade, July 1st, 2025. NASA announces a new detection, an interstellar object barreling through space at over 200,000 kilometers per hour. They call it 3I Atlas. And just like Oumuamua, it refuses to behave the way a natural comet or asteroid should. Its brightness seems wrong. Its trajectory seems intentional. And the closer scientists look, the stranger it becomes. So let's imagine for a moment, what if Oumuamua really was an alien spacecraft? And now 3I Atlas is proving it wasn't the first, and maybe not the last. What would that mean for science, for our place in the universe, and for the future of humanity? In the next 15 minutes, we'll explore this mind-bending possibility. We'll revisit the mysteries of Oumuamua and why so many scientists were baffled. We'll dive into the new discovery of 3I Atlas and the evidence that S-making experts question if it's natural at all. Finally, we'll ask the biggest question of all. If these interstellar visitors are on just rocks but technology, then who sent them and why? This isn't just a story about comets or asteroids. It's about the possibility that our solar system has already been visited, maybe even watched, by civilizations far older and more advanced than our own. So buckle up. Because whether Oumuamua and 3I Atlas are simply strange cosmic rocks, or the first evidence of alien technology, the truth could change everything we think we know about life in the universe. Welcome to Astronomical Library. In October of 2017, telescopes in Hawaii picked up a faint streak of light moving rapidly against the background of distant stars. At first, astronomers thought it was just another asteroid within our solar system. But within days, they realized this object was on a trajectory unlike anything we had ever recorded before. Its orbit had an eccentricity greater than 1, meaning it wasn't bound to the sun at all. This wasn't a local rock. It was something arriving from interstellar space. Humanity was witnessing the very first confirmed interstellar visitor to our solar system. They named it Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. And the name was fitting, because nothing about Oumuamua matched what scientists expected. When astronomers tried to estimate its shape, the data showed it was extremely elongated. Unlike the roughly spherical asteroids and comets we're familiar with, some calculations suggested it could be 10 times longer than it was wide, like a cosmic cigar or even a flattened pancake. But the real mystery came when Oumuamua began to accelerate. Objects like comets sometimes speed up because sublimating ice creates jets of gas that push them forward. Yet Oumuamua showed no visible signs of outgassing. No tail, no glowing coma. Nothing. And still its speed changed as though an invisible hand was nudging it along. Many in the scientific community, this was unsettling. It was the first time we had ever seen something so alien to our expectations, and the data simply didn't add up. That's when Harvard astrophysicist Avi Loeb made headlines. He published a provocative argument. Perhaps Oumuamua wasn't a rock at all. Perhaps it was a piece of technology, a light sail, or even a probe, designed by another civilization and drifting through the galaxy. The suggestion was met with both fascination and skepticism. Some scientists dismissed the idea as speculation bordering on science fiction. Others admitted privately that there were no easy natural explanations. Oumuamua stayed in our telescopes for only a few short weeks before disappearing into the dark. leaving behind a trail of questions we still haven't answered. Was it simply a bizarre fragment of a shattered planet? Was it a frozen shard of hydrogen ice, invisible to our instruments? Or was it something far more extraordinary, a messenger from another world that passed by too quickly for us to truly study? One thing was clear: Oumuamua had shattered our assumptions about what could wander into our solar system. And for the first time, Man's scientists were forced to grapple with the possibility, however remote, that we might not be alone. On July 1st, 2025, astronomers made an announcement that immediately captured headlines around the world. A new interstellar visitor had entered our solar system. It was designated 3I Atlas, the third confirmed object from beyond our sun. At first, many assumed it would be another Borisov, a fairly standard comet drifting in from interstellar space. But the more scientists looked, the clearer it became. Atlas was anything but ordinary. Initial calculations showed that Atlas was traveling at over 200,000 kilometers per hour. That speed, combined with its orbital eccentricity being well above 1, meant it was not gravitationally bound to the sun. This was a true wanderer from the stars, cutting across our solar system on a path that would eventually fling it back into interstellar darkness. But while its velocity confirmed its alien origin, its trajectory sparked the first wave of controversy. Atlas was following a retrograde orbit, tilted only about 5 degrees from the ecliptic, the same plane where Earth and most planets orbit. Statistically, the odds of such alignment happening purely by chance were minuscule, roughly 0.2%. Why would a random interstellar comet arrive so neatly aligned with the architecture of our planetary system? Then came the question of light. Normally, astronomers measure brightness assuming an object is reflecting sunlight. Based on Atlas's glow, calculations suggested it was an enormous body, nearly 20 kilometers in diameter. That would make it a true giant, 40 times larger than Oumuamua, and vastly more massive than Borisov. But Avi Loeb and Eric Kito challenged this assumption. Using brightness profiles from the Hubble Space Telescope, they noticed something peculiar. Atlas' glow didn't follow the same gradual fade typical of comets. Instead, it had a much steeper brightness curve, consistent with an object that wasn't just reflecting light, but potentially emitting its own illumination. If that were the case, Atlas might not be a colossal rock at all. It could be dramatically smaller, perhaps only a few hundred meters across, but with a power source generating its glow. Nuclear decay, thermal emission, artificial lighting? Each possibility raised more questions than answers. Spectroscopic data from the Gemini South Telescope and NASA's Infrared Telescope facility revealed strong signatures of water ice, along with carbonaceous minerals and silicates. On paper, that sounded like a comet. But here's the twist. The water appeared chemically pristine, lacking the heavy isotopes we usually find in solar system comets. That suggested it might have formed in a completely different stellar nursery billions of years ago. Some scientists proposed a provocative idea. What if the icy dust wasn't part of Atlas's core, but instead a coating accumulated during its journey through interstellar space? In other words, the true object beneath could be something entirely different, perhaps even artificial now, disguised by eons of drifting debris. Atlas's projected path only deepened the intrigue. Over the coming months, it would have close encounters with multiple planets. On October 3rd, Atlas would pass within 29 million kilometers of Mars, close enough for spacecraft in Martian orbit to attempt higher-resolution imaging. On October 29th, it would reach perihelion at 1.35 astronomical units. But from Earth's perspective, this crucial phase would be completely hidden behind the sun's glare. If Atlas were conducting maneuvers or revealing its true nature, we wouldn't be able to see it. Avi Loeb dubbed this timing a potential reverse O-berth maneuver, a clever strategy for a spacecraft to use the sun's gravity to break or adjust its orbit while avoiding scrutiny from Earth. Later, it would swing close to Jupiter, within about 33 million kilometers. Skeptics pointed out a serious challenge. If Atlas were truly generating its own light, it would require around 10 gigawatts of continuous power, equivalent to several large nuclear power plants. Could such an energy source really sustain itself for millions of years of interstellar travel? If so, it would imply a level of technology far beyond human capability. As excitement built, astronomers split into two camps. On one side, researchers like David Jewett at UCLA emphasized that Atlas, its dust production rate between 6 and 60 kilograms per second, matched known cometary activity. Its dust ejection velocities, ranging from 2,000 meters per second, also fit natural patterns. For them, Atlas was an exotic but natural comet. On the other side, proponents of the artificial hypothesis noted that the timing, trajectory, and light emission all raised red flags. For them to dismiss Atlas as just another comet would be ignoring extraordinary evidence. The truth, scientists agreed, would be decided by observation. As Atlas approached the Sun, telescopes like James Webb would search for the telltale chemical emissions of a comet, cyanogen, diatomic carbon, and others. If those failed to appear, the artificial hypothesis would gain credibility. Meanwhile, engineers at NASA and ESA debated whether to retarget instruments already in orbit. The HiRISE camera, aboard the Mars Reconnaissance Orbiter in particular, was suggested as a tool that could capture close-up images during Atlas's Mars flyby. A single detailed picture could determine whether we were looking at an ordinary icy nucleus or something far more extraordinary. For now, Atlas continued its silent journey, glowing mysteriously against the backdrop of space. Was it a frozen relic from another solar system? Or was it the second act of a cosmic drama that began with Oumuamua in 2017? Because if Atlas isn't natural, then Oumuamua might not have been either. And that would mean humanity has already been visited by alien technology, not once, but at least twice. When Oumuamua slipped silently out of our telescopes in late 2017, it left behind more questions than answers. For years, scientists debated what it really was: a shard of rock, a hydrogen iceberg, a fragment of a shattered planet, or perhaps something far more exotic. Many agreed. We might never know, since it vanished before our best instruments could study it in detail. And then came 3I Atlas. Suddenly, the mystery of Oumuamua didn't feel like a one-time anomaly anymore. Now we had not one, but two interstellar visitors, each arriving with its own set of baffling behaviors. When placed side by side, the similarities are hard to ignore. Oumuamua entered the solar system on a hyperbolic path that made little sense. If it were simply a comet, its velocity was unusually high, and most puzzling of all, it accelerated without any visible outgassing. Similarly, Atlas arrived on a hyperbolic trajectory, but one aligned with our planetary plane to a degree of precision that seemed improbable. Both objects traveled in ways that natural dynamics struggled to explain. Oumuamua's shape was inferred as highly elongated, unlike anything we'd ever seen. It reflected sunlight in ways that suggested either a cigar-like structure or a flat, pancake-shaped body. Atlas, meanwhile, was initially thought to be a gigantic 20-kilometer object, only for its brightness profile to raise suspicions that it might be producing its own light. Both objects challenged our standard assumptions about how size and brightness should relate. Astronomers estimate that catching a true interstellar rock, especially something on the scale of 20 kilometers, should happen maybe once every 10,000 years or more. Yet in less than a decade, we've now observed two anomalous visitors, both with strange characteristics. Statistically, this stretches credibility. If these are natural, then perhaps our models of interstellar debris are deeply flawed. But if they aren't, then something else is at play. Oumuamua arrived and was gone within weeks, before we could train our most powerful observatories on it. Atlas II carries with it an inconvenient timing. Its closest solar approach happens when Earth cannot observe it, hidden by the glare of the sun. To some, this is just cosmic coincidence. To others, it's eerily suggestive, as if these objects arrive and maneuver in ways that deliberately minimize scrutiny. In both cases, the scientific community split into two camps. With Oumuamua, some argued for exotic but natural explanations, while others admitted we lacked the data to be certain. With Atlas, the debate is repeating itself. One side points to cometary activity, while the other insists the anomalies are too great to ignore. Both objects highlight the limits of our understanding, and the tantalizing possibility that what we are seeing might not be natural at all. Taken individually, Oumuamua and Atlas are scientific curiosities. Taken together, they suggest a potential pattern. Unusual visitors entering our solar system, displaying behaviors that defy simple classification and leaving behind mysteries that deepen rather than resolve. So the question becomes unavoidable. Is this pattern the product of random chance, or the signature of something intentional? If Oumuamua was the first probe, is Atlas the second? And if so, how many more are out there waiting to be noticed? If Oumuamua and 3I Atlas were simply cosmic rocks, then the story ends here. Strange, yes, but ultimately just natural quirks of a vast universe. But what if they aren't? What if the peculiarities we see aren't accidents, but signatures of engineering? When Avi Loeb first proposed that Oumuamua could be an alien probe or light sail, many in the scientific community balked. The idea seemed too speculative, too radical. But Loeb pointed out the undeniable. Oumuamua's unexplained acceleration could be consistent with sunlight pushing against a thin, artificial sheet, like a solar sail. Its elongated or flattened shape fit the profile, and its lack of gas emissions meant no natural cometary explanation quite worked. For Loeb, the simplest explanation was that Oumuamua was not a natural comet, but a technological relic, perhaps a probe designed to travel between stars, silently slipping through planetary systems to gather information. With Atlas, the case becomes even stranger. If its brightness profile truly indicates self-illumination, that would suggest some form of internal energy source. Natural explanations like radioactive decay or thermal heating seem inadequate. They cannot sustain a consistent glow for millions of years of travel. That leaves us with a provocative possibility. Atlas could be powered, a spacecraft. The timing of its trajectory raises further suspicion. Its perihelion, hidden behind the sun from Earth's perspective, is exactly when a spacecraft might perform maneuvers to alter its speed or orbit. Avi Loeb even called it a potential reverse Oberth maneuver, a clever way for a craft to slow down using the sun's gravity, while concealing the entire event from Earth-based observation. Coincidence or design? Some scientists noted that Atlas's spectrum contains familiar cometary signatures. Water ice, carbon silicates. But what if that's camouflage? If Atlas were truly a probe, traveling through interstellar space for millions of years, it could accumulate cosmic dust and frozen material along its surface, a natural disguise that makes it appear like a comet. Beneath that layer of debris, there could be something very different. A structure, a machine, a vessel. If these objects are probes, what purpose might they serve? One possibility is simple reconnaissance. Civilization on Earth is only now developing technologies capable of detecting interstellar visitors. An advanced species could have been sending probes like these for millennia, quietly monitoring emerging life in the galaxy. Another possibility is that they aren't meant to communicate at all, but to persist. Imagine thousands of such probes scattered across the stars, each designed to survive for eons, gathering data passively until some intelligent species stumbles across them. They might not even need to be active in the way we think of spacecraft. They could be autonomous archives, time capsules, or even seeds of technology drifting between stars. If both Oumuamua and Atlas were technological artifacts, then humanity has already been visited. Twice, in less than a decade. That alone would shatter our understanding of our place in the cosmos. And yet, if they are probes, they seem strangely silent. No radio signals, no obvious attempt at contact, just quiet passage. If they are watching us, what are they waiting for? If they are scouting, what comes next? Whenever the idea of alien technology enters the conversation, the scientific community reacts with caution, sometimes even outright dismissal. And with both Oumuamua and 3I Atlas, skepticism has been strong. Most astronomers argue that while Oumuamua was strange, it was not necessarily alien. Some proposed it was a fragment of a planet ripped apart by tidal forces, flung into interstellar space, and shaped into an elongated shard. Others suggested it could be a hydrogen iceberg, made of frozen molecular hydrogen that sublimated invisibly, providing thrust without the visible tail of a comet. There were even theories about nitrogen ice, perhaps a chunk chipped off the surface of a Pluto-like planet in another system. Each of these models attempted to explain the mysterious acceleration without invoking alien technology. But critics of these natural theories pointed out problems. A hydrogen iceberg would evaporate too quickly. Nitrogen chunks would be unlikely to survive long enough, and the exact shape of Oumuamua still defied expectations. Nevertheless, many scientists preferred these scenarios to what they saw as the far more extraordinary claim of alien engineering. With Atlas, skepticism is just as strong. Observations show dust production rates between 6 and 60 kilograms per second, which fits neatly within the expected range for cometary activity. The ejection velocities between 20 and 2,000 meters per second also match the physics of comets. David Jewett of UCLA, analyzing Hubble data, noted that these are classic signatures of cometary behavior. For him and many others, the simplest explanation remains the most likely. Atlas is a natural comet, albeit one arriving from interstellar space. The mysterious glow. Skeptics argue it could still be explained by dust grains reflecting sunlight in unusual ways, or by outbursts too subtle for our instruments to resolve. And the idea of Atlas being self-luminous, generating its own power, faces a severe challenge. To shine as brightly as it does, Atlas would need to generate on the order of 10 gigawatts of power, equivalent to several large nuclear plants operating continuously. For a natural object, this is impossible. For an artificial one, it implies technology so advanced it verges on science fiction. There's also a philosophical principle at play. Extraordinary claims require extraordinary evidence. For most astronomers, invoking alien technology without clear, direct proof is premature. They argue that history is full of cosmic mysteries that once baffled us, from pulsars, first nicknamed LGM for little green men, to gamma-ray bursts. Each time, the explanation turned out to be natural, not alien. Could Oumuamua and Atlas simply be the latest entries in this tradition? Phenomena we daren't yet fully understand, but which will eventually yield to natural explanations? For scientists, the solution is patience and data. As Atlas approaches perihelion and then makes its close pass of Mars, instruments like the James Webb Space Telescope and the HERE-ISE camera on the Mars Reconnaissance Orbiter may finally reveal decisive clues. If Atlas truly is a comet, we should soon see the unmistakable chemical signatures of sublimating gases. If not, then the debate will only grow louder. Until then, the official consensus remains cautious. Atlas is most likely a comet, just as Oumuamua was most likely a natural shard of rock or ice. The alien probe hypothesis, for now, lives on the fringe. Intriguing, but unproven. So where does that leave us? Oumuamua has already vanished into the dark, taking its secrets with it. Atlas is still here, streaking through our solar system, offering us a rare second chance to study an interstellar visitor in real time. For the first time in human history, we may have the tools. The James Webb Space Telescope, the Vera Rubin Observatory, and even spacecraft orbiting Mars, to capture details that were impossible just a few years ago. But the stakes are enormous. If Atlas reveals itself to be nothing more than a natural comet, then we will have gained invaluable knowledge about interstellar chemistry, the birthplaces of planetary systems, and the diversity of cosmic debris. That alone would be a triumph of science. Yet, if the anomalies persist, if the evidence continues to resist natural explanation, if its brightness, trajectory, and timing remain suspicious, then we are faced with something far more profound. Because if Oumuamua was the first probe, and Atlas is the second, then humanity has already been visited by technology from another civilization. And that discovery would not just change astronomy, it would change everything. Our place in the cosmos, our understanding of life, our future as a species. Think about it. The universe is 13.8 billion years old. Other civilizations, if they exist, could be millions or billions of years ahead of us. For them, sending out probes like Oumuamua and Atlas might be as routine as launching satellites as for us today. These objects could be scouts, archives, or simply cosmic breadcrumbs left behind by explorers who moved on long ago. And if that's true, then the question is no longer are we alone? The question becomes, have we already been noticed? As we await the next critical observations in the coming months, the Mars flyby, the hidden perihelion, the Earth return in December, one thing is certain. We are living through a turning point in human history. Whatever atlas turns out to be natural or artificial, it reminds us that the universe still holds secrets vast enough to shake our imagination. So, what do you think? Is Oumuamua just an odd rock? Is Atlas really a comet? Or are these visitors signs of something extraordinary? The first whispers of alien technology in our own backyard. Share your thoughts in the comments. And if you crave more journeys into the mysteries of the cosmos, subscribe now, because the story of the universe is only just beginning.